So we're going to first look at expanding some expressions. So as you can see in examples 1 through 5, right now they're currently all condensed because they all have a single log in them. If they were expanded, they would have multiple logs in them. So we're going to look at 3, 4, and 5. So let's do number 3. So when this is expanded, the u and the v will both have a log base b with them. So I'm going to start with figuring out if we're adding and subtracting first. So if this is u squared times the square root of v, if those two things are getting multiplied together, that was your product property, where they're now going to get added together. So both the u and the v will get a log base b. So it'll be log base b of u squared plus log base b of the square root of v. Now, we can't have square roots, so we have to remember back from unit 3 that the square root of v, the square root, if we rewrote that in exponential form, the u squared I'm just going to keep for right now, but we can rewrite log base b square root of v as log base b v to the 1/2, because remember that index is 2. So now the last thing we need to do to make sure it's expanded is just move your exponents to the front. So this becomes 2 log base b of u plus 1/2 log base b of v. So we did two things there. We figured out what operation we were using. In this case, we needed addition, and then we moved or took care of those exponents. And then that one is done. So if you look at number 4, we've got a log base 2 now instead of log base b, but the f, u, and n, oh, spells fun. All 3 of them are going to get a log base 2. We just have to figure out which ones are getting added and which ones are getting subtracted or going to be negative. So in this case, we'll have log base 2 f to the negative second. So anything on the top will be a plus. Anything on the bottom will be a minus. So since f and u are being multiplied together on the top of our fraction, it will get a plus log base 2 of u. And then the n to the 8th is going to be minus. And then the last thing we have to do is move any exponents that we have. So that negative 2 exponent and that power of 8 both have to get moved to the front of that specific log expression. So this will now be negative 2 log base 2 of f. U is fine because it doesn't have an exponent. And minus 8 log base 2 of n. So we had 3 letters, f, u, and n. We now have 3 log expressions. And we took care of the exponents, which was our last step. So then if we look at number 5, we've got another log base 2, but we've got a number here in this case. So it's important to know that the 3 and the x are separate. So when we're done here, the 3, x, w, and y are all going to have a log base 2. So we'll have everything on the top is positive. So positive log base 2 of 3. All on the top, all being multiplied together. So log base 2 of 3 plus log base 2 of x plus log base 2 of w. And then your y to the 4th will be a subtraction or a negative. Okay, so the only one with an exponent was that y. So your 4 will get moved to the front. So this will just become log base 2 of 3 plus log base 2 of x plus log base 2 of w. And then minus 4 log base 2 of y. So I know this can get kind of confusing because there's a lot of subscripts, superscripts, trying to figure out how what is written. So just know, so like in this example, log base 2 of x, say. The log and the x are on the same line, so to speak, and the 2 is the subscript, the little value. So like your log base 2 of y to the 4th, up here, your log and your y are on the same line. 2 is the subscript, 4 is the superscript or the power. It's important to be able to understand what you're looking at so you know how to use your properties correctly. So why don't you guys try the first 2?